Hello friends, in this video we are going to know about an auto transformer. Actually the normal transformer consisting of two windings, uh, voltage source under load or no load. Okay, but what is the speciality in this auto transformer means the transformer having a single winding, but it's performed like a two winding transformer. Here you can see the diagram of an auto transformer. um, ABC is a winding of primary and B and C is a secondary winding, which means the part B and C which is common to both the winding, and the voltage source V1 is applied to the primary winding ABC, and the load is connected to the secondary winding B and C. Here you are seeing the step down auto transformer in this picture. Actually the role of the step down transformer is to stepping down the power from greater amount of voltage to lower voltage. Okay, let us assume the applied voltage V1 which is present on the high voltage side as a V1, and the output voltage we are getting from the load which present in the lower voltage as V2, and the input current which was produced by the input voltage and it was in a high voltage side as I1, and the number of turns of primary winding which means the full winding A B C as N1, and the number of turns of the secondary winding which means we are considering the winding part B and C as N2, and so here we are knowing the notation for the winding B and C which is common to both as N2, and the primary winding A B C as N1, but we have to know about the remaining winding of A and B, what is the notation will be, and the series winding A and B having the notation N1 minus N2. And this is important to know about the voltage transformation ratio, and this is the concept how the power gets delivered from the primary voltage to the load. Actually in order to calculate the power, so power is equal to voltage into current, right? So we have to know the power factor on secondary side. So we are considering power as P2 is equal to voltage V2 and I2. So the voltage V2 is known factor, but the current I2 which passing to the secondary winding is unknown. Okay, actually the current which passing from the supplied voltage we are considering as I1, right? And the current which flowing through the secondary winding as I2. Then what will be the current passing through the common winding B and C? Okay, it is confirmed that the current I1 which is coming from the supplied voltage V1 and it is passing through the primary winding as well as secondary winding, and the current I2 is coming from the winding that is as I2 which is going to passing to the load. Then what will be the current which is flowing in the BC winding? So we are taking I2 minus I1 is the current factor which passing through the BC winding. So the secondary current I2 that is equal to I1 plus I2 minus I1. By applying the I2 in the formula of power, we are getting the equation, and the power is transferred from the applied voltage to the load as two parts. One is one, the power is directly transfer from the power source to the voltage through the winding A and B, and it is indirectly passing through the load by the winding B and C. So these are the two forms of ways the power gets transferred to the load. So the first form of power is transferred to load is V2 I1. So it is directly transferred from the voltage source to the load, right? So V2 I1 divided by V2 I2, that is the V2 and V2 which was present in both denominator and numerator gets cancelled, and we are getting I1 by I2. According to transformation ratio, I1 by I2 is equal to K. So the power transferred through directly from AB winding, that is equal to total power transferred to load into constant K, and the second part of the power is V2 I2 minus I1. So this is the power transfer indirectly to the load by through BC winding. So similarly, we are applying the power factor on BC winding divided by the power gets transferred to load. After solving this condition, we are getting the answer 1 minus K. By the way, let's we see about how the step up auto transformer is working. Okay, in step down transformer, up to winding it is considered as a high voltage side, and after winding it is considered as low voltage side. But opposite to the step down, the step up to the winding having the low voltage side, and after the winding it is as a high voltage side, because the role of the step up transformer is to converting the lower voltage to a various amount of higher level voltage. Okay, the transformer is slightly different when compared to the step down. Okay, in step up, the primary winding is B and C, and the secondary winding is A, B and C. So it's look like just opposite to the step down transformer, right? So the primary winding B and C, the voltage source is connected to it, and the load is connected to the full winding, that is the secondary winding AC. So in the step up transformer, the B and C are the common part of winding for both the primary and secondary. So far we dealt with the step up and step down auto transformer, and the benefit of auto transformer is to saving a large amount of copper when compared to the two winding transformer. Let's we discuss about how the auto transformer saves copper a large amount when compared to the two winding transformer. Okay, in order to know about the weight of the conductive material, that is copper, we have to know the length of the copper wire as well as number of turns present in it. So the weight is directly proportional to its length, and the length is directly proportional to number of turns present in the coil. Okay, so we are taking the weight of the copper in primary as N1 and I1, number of turns, and the how much of current gets passed through the winding N1. Okay, similarly the weight of copper on secondary as taking as N2 I2. So the total weight of the copper in a two winding transformer is by adding both primary and secondary. But in auto transformer we are having single winding, right? So we have to calculate separately the weight of copper on AB winding and BC winding. So in order to calculate the section AB, so far we discuss about it. The N1 winding is the A and C, and the secondary winding is B and C. Then the part of the AB series is considered as N1 and N2. So the weight of copper in AB section, number of windings and current is N1 minus N2 into I1. Similarly, for the section B and C, the number of windings and the current gets passed into it, N2 into I2 minus I1. Okay, so the total weight of copper in auto transformer is by adding the section A, B and BC. So we have to know how the auto transformer is efficiently saving copper when compared to the two winding transformer, right? So for this we have to divide both the terms, that is weight of copper which was used in auto transformer divided by, and what is the amount of copper which was used in the two winding transformer. By dividing both the terms, we are getting the answer 1 minus K into weight of copper in two winding transformer, that is the auto transformer saved copper in 1 minus k terms, and it was gets multiplied by the amount of copper which was saved by 2 winding transformer. So saving will increase in auto transformer. So k is equal to 1. Within the single winding, the auto transformer saves a large amount of copper when compared to the two winding transformer, and it acts like a two winding transformer, and it automatically works upon the voltage what we are given to and what will be the output. So this is the auto transformer. I hope guys you all well known about the auto transformer and its working through this video. um, if you feel any feedback, try to fill it in the comment page. Thank you. Please subscribe for more videos.